In this lecture, I'm going to talk about selection of your compute platform. So remember, right, we have talked about databases and all aspects of it, including data lakes and data warehouses. What you're still left with is still the fundamental choice of where do you run your business logic, right? So essentially, let's say you want to uh, create a ranking function for a list, right? Where does that ranking function list? Which compute platform do you use to host it? So before we answer that question, it's really important to understand the entire layer by layer architecture of how a business logic is implemented. So let's take the simplest example of a virtual machine. So this is, think of this as getting a VM from EC2. And now what do? You essentially figure out the OS that you want. Then you decide the web container. For example, you can choose Tomcat. Then you wrap your application as a web application. And then within that web application, there is your business logic. Now, of course, you can have an application that doesn't run on a web container. You may have a different kind of application, but this is a very common case. The fundamental aspect that you need to understand here is that anything at the OS layer and above is something that you need to manage. So whether you need to basically patch your OS because a new security issue has come up, it is your responsibility. Compare that with, let's say, you have a container. In the case of a container, you're running on top of an OS. So you don't have to go and patch the OS. You don't have to worry about the OS. But what you still need to do is go and deploy your Tomcat, then your web app, and then within that web app, you will have your business logic. So that is how a container operates. Uh, and containers, when I say containers, think of them as Dockers or any other container notion that you have. You can go even further up and you can basically deploy your web app inside one of the web containers that is available as a service. So think of this as basically an app runner or Google app run or AWS app runner. All of these essentially where you don't even have to go and worry about deploying your own Tomcat or your WebLogic web container. You just have to build your web app and that web app runs inside the web container that is provided by the cloud provider. Now, of course, here you have the advantage that you don't have to worry about, let's say, upgrading your Tomcat from version 6 to 7, or again, fixing a patch and stuff like that. You don't have to worry about setting the max threads on your Tomcat. You don't have to worry about a lot of these other things. You can go even higher up where you just embed your business logic, you code it up and then wrap it in a Lambda function and then deploy that Lambda function. Essentially, you don't even have to build any kind of routing. All you do is you say this Lambda function basically will listen to this event and will take an action. So in here, you don't even have to do the wrapper there. One of the other thing that is very unique about a Lambda function is that now this logic is running standalone. There is no container within which it is running. So every other option before it, right? Whether it's a VM or a container or an app run, you are getting a container and then you are running multiple requests within that container. When you look at a Lambda, not only do you actually get rid of all of these layers, your logic is running independent of any other request. So there is no notion of grouping things in a container and running multiple things concurrently within a container. So with that out of the way, right? I think there, when you want to basically make a selection of a a platform, the first question that you need to answer is what kind of dependencies do I have? Do I have a hard constraint on any of the layers? And this is what I'm calling tier one questions, right? So the tier one questions will tell you that, oh, you need to run essentially below a certain layer. So basically, for example, right, if you have a dependency on the operating system itself, you have no choice but to control the operating system, which means that you can only run on VMs where you have to take control of the operating system. You can even have a choice where you actually need a dependency on the physical server. I need a specific kind of hardware, in which case you can't even run on a VM. But let's keep that aside. But basically, the tier one question essentially place hard constraints, saying, I have a dependency, my application can only run on, let's say, Tomcat 6. In which case, you will have to go and deploy your own Tomcat. In which case, you cannot run it inside a web container that a platform provider gives you. At the very minimum, you need a regular container, an OS level container in which you can go and deploy your own Tomcat. And similarly, if you have a specific dependency on running something on Ubuntu 14 only, there's no way you can run it on anything other than uh, deploying your own VM. So basically the tier one question essentially you need to ask in the order, right? Do I have a dependency on the operating system? Maybe I need a specific file system. In that case, I have to basically the only option that I have is basically getting a VM. Do I have any dependency on the web container? Specific Java versions that I need to support, stuff like that. Do I need to even package my application as a web app? For example, if you don't even need to package your application as a web app, then your Lambdas become a choice. But if creating the application as a web app is a requirement, then basically Lambda is no longer a choice. So the tier one questions essentially say, I can only run at a layer this and below, simply because I have a dependency on something at this layer of the compute stack. So now let's look at what are the secondary level questions that you have to answer when you, let's say, decided that you need to run your applications on VM. So again, right, you will run applications on VM. Then you have a straightforward choice on most clouds. Typically, there will be a single choice, right? If it's AWS, it will be EC2. So you have to go for EC2. And of course, it's making sense only if you have an OS or a system tool requirement, which means that you need to control the operating system. Once you decide you want to run on, for example, EC2, then you have three choices. And these are like common across all platforms. You can go for reserved, you can go for spot, or you can go for on demand. Now, one thing that I want to highlight here is that compute is actually a gray area, compute selection, right? It is part architecture, it is part cost optimization. We as architects should not worry about cost optimization as much. And part of the reason is that cost varies based on pricing, and the pricing is something you cannot control. Means someday spot instances may be expensive compared to, let's say, keeping, let's say, on-demand instance because you have workload that's consistent. But suddenly AWS decides to change the price for spot, or AWS decides to change the price for reserve. Now, if you change your decision, it is not a technical decision, it's a pure pricing based decision. So this secondary decision point is actually not an architectural decision. It's actually a cost decision and something that you'll probably keep on changing every few months as essentially the prices change. So that's something that you should not even spend a lot of time on. The important thing that you need to care about is, do I have a dependency which forces me to use an EC2 because I need a specific versions of the OS. Now the second choice, right? When you are running applications as containers, here the secondary decision point is there, which essentially saying, okay, what kind of container management do I use? So what you can do is basically you can install your own control plane. Why would we ever do that, right? If you've decided that you need to run as containers, then to deploying the control plane is wasteful. I mean, you're on a cloud, there's no reason to actually go and add that complexity unless you're in this business of infrastructure management and you are very, very familiar with Kubernetes. The second option is to basically use the provider's managed Kubernetes, which essentially, for example, on AWS, it's an EKS service. The third option is in some platforms, basically, there is an opinionated version of the Kubernetes platform that is simpler to manage. For example, ECS on Amazon. Here again, right, I think the first option is something that you should almost always rule out, and you end up with EKS versus ECS. And this is actually a technical decision that you need to make. If you need low-level Kubernetes functionality, only then use EKS. Otherwise, don't use EKS because it's going to be much harder to manage. So you should always prefer, again, something that is higher up the stack, gives you less control, but that control is something that you can live with. So again, ECS over EKS if possible. If you need core capabilities of Kubernetes, then basically go for EKS. The second decision point that you need to make is where exactly do you host your cluster, right? So there's this control plane, and then there are your compute nodes that need to basically get hosted. Control plane, you have three choices, right? Install your own control plane, use EKS, use ECS. I'm taking AWS as an example. Then you have to look at your nodes. Where do you host your nodes? You have two choices, serverless versus you host them on basically VMs. Now, if you have workloads that will vary, and most workloads will vary over a period of time, it is always preferred to go with serverless because you have zero maintenance. So you don't have to worry about creating VMs, then deploying your containers on top of them, and then when you need to scale up, add more VMs and so on and so forth. Most cloud providers will give you the ability to auto scale. So basically, with ECS also you can auto scale with EC2, but that is essentially still an extra overhead as compared to just using something like a Fargate, which is completely zero maintenance. So when you're looking at containers, this is how you start with. You say, I will see if I can run my stuff on ECS with Fargate. If for some reason I cannot, and if the limitation is with ECS, then I will actually go to EKS. On the compute node side, you will say, I will run Fargate by default, but in case I realize that I have very, very stable workloads that don't vary a lot, and I want to actually save a bit on cost, which is actually not a technical decision, it's more of a pricing decision. Then in those cases, I will skip Fargate and go to EC2 and use EC2 automated scaling. Next, let's move to the next two options, and these are actually more interesting options from a pure technical perspective. So the two options that we have are basically things which run inside a web container like an app runner, and then completely standalone compute logic that you encapsulate as a Lambda function. So how do you differentiate between these two? So first is essentially the workload type. You use something like an app runner when it's again a traditional request-based structure where you have customers who are making requests to a web application and the web application needs to serve them. Then that is a classical use case for app runner. On the other hand, Lambda is more relevant when you essentially are looking at more of an event-based architecture where an event happens and you want to do something. Then you use a Lambda. Because an app runner, essentially you are running inside a container and you can actually do complex processing. So you get a request, right? That request may actually need to touch 4 different things. So you can actually do thread management there. And this thread management essentially you will have to do in your own code. In the case of a Lambda, you will generally do one thing at a time, and that's why there should not be any thread management. Similarly, right, if there's a DB, then you will do DB connection pooling because there are again multiple requests running inside the same container. Whereas in the case of Lambda, you will not do any kind of connection pooling. If you need connection pooling, then Lambda is probably not a great choice in any case. There are ways to do that. You can do that using proxies or essentially functions which hold variables that you can move things around. But those are essentially not ideal. In a container, you can have long running request, whereas in a Lambda, you're limited by 15-minute interval. And these are numbers that will change. So you cannot basically make a decision just based on these things. Now, there are two important things that we need to understand. One is something that differentiates App Runner and Lambda from containers and VMs. Both App Runner and Lambda are meant for simple requests where the variability across requests is not very high. And let me explain that a bit more in detail. In a web container, what you expect to do is you expect to serve very similar requests. The kind of flexibility you have is limited. And mostly what you're looking at, mostly your concurrency is based on the number of concurrent requests that are running. It is not based on the resource utilization. So if you have very variable request, then the way you're going to set your concurrency, it's never going to work. So assume you set your concurrency to 100, but there are some category of requests which are 10 times more expensive than the other categories. Then effectively, what will happen is that whenever there is a burst of this more expensive request, even though you don't hit your concurrency limits, you will actually see performance dip. And that is why in something like an app runner, you should always have requests which are similar. Lambda again, right? This should all be simple request, because if something is long running and hits your 15-minute interval, then that thing is going to fail. So you should always have like simple homogeneous kind of request that you run with app runners or lambdas. If you have more complex things, then that is one reason to go with a VM or a container, even though theoretically your application could run at a higher layer. One thing that actually completely differentiates Lambda from all the other choices is the isolation. So this is something that, I mean, some of you should be obvious by now, right? In a Lambda, you're running one compute element completely independent of anything else. There's nothing you're sharing, which essentially means that if you have one bad request, it's not going to impact others. And this actually is very useful. So it is very likely you will not have cascaded failures if you go for a Lambda-based model. That is a significant advantage, because very often in many cases what you see is basically some bad request basically queuing up, taking away resources, and unless you have very good implementations of essentially a circuit that you can cut off, you end up basically your server essentially starts to get choked, and then everything essentially cascades back up all the layers. With Lambda, that can never happen, simply because every request is served independent of other requests. So even if you have one bad request, that will get stuck, everything else will keep on running. That bad request will time out in 15 minutes, and then it doesn't matter. The, the disadvantage of actually this architecture is that nothing can be shared, right? Because these independent events are being handled independent of each other. So there's nothing you can share. You can have ways to sharing, but if you actually need a lot of sharing, then Lambda is not a good choice. So this gives you a very, very high level summary of the 4 choices we have. And then let's look at the final selection, right? So basically the rule of thumb, of course, was, right, you have to prefer compute level which is at a higher layer, so that you minimize the overhead of maintaining lower layers. So of course the tier 1 questions, right, they will tell you, this gives you a hard constraint. I need to run on container and below, or I need to run at a web container and below. Once you have made those hard constraints, saying now you have choices which are anything below that level, then there are only 2 questions you need to ask, right? How complex is the request? If the requests are complex, then don't go for app runner or lambda. The second question that you need to ask is, what information do the requests need to share? If the requests do not need to share anything, then lambdas is a possibility. But if the requests need to share a lot of stuff, then you should not use lambda. But in case, basically, right, all the questions essentially give you multiple choices, then out of those choices, it is recommended to go at as high a layer as possible. So if your application based on these questions can run both on Lambda and App Runner, go for Lambda. If based on these questions, your application can run on basically App Runner as well as, let's say, containers, then go with App Runners. So that's essentially, in a nutshell, is the way you do compute selection. This just leaves one last thing, essentially caching, and that's what we're going to cover essentially in the next lecture.